For this problem, we are going to figure out the pressure of the unknown gas that we are adding. What we're going to do is we're going to start with a tank that has air in it. It's open to the atmosphere, and we can find that the outside pressure is 753. We're going to hook this tank up to vacuum, and we're going to remove some of that air. Well, we had the outside pressure pushing down, and originally the inside was the same, but we just made it smaller. We got rid of some of that inside pressure. The result is that we are going to lower the mercury level on the outside, and we're going to increase it on the inside. What we will find in the end is that there's a height difference between the two layers, which means there's an extra pressure of mercury now on the inside. Well, that height difference is 7.8 centimeters due to vacuum. And then we let it settle there for a minute, and we open the gas tank. And some of the gas flows into our reactor. Well, now I have more pressure from the gas, and so it is going to change my levels. What we will find is that the mercury goes down on the inside and up on the outside, and we end up here with a height difference of 11.3 centimeters. It's 11.3 centimeters after new gas. My question is, what is the total pressure on the inside? And also, find the pressure of the gas. Go ahead and pause, see if you can use this info to solve both of those. All right, well, if you're back, well, pressure total on the inside, that's just the sum of everything. The idea is I have some regular air still on the inside. We never got rid of all of it. You can see we left some dots of it over here. And we have some gas, of the unknown gas. They're both pushing down on the mercury level on the inside. Well, over on the outside, I've got my outside pressure pushing down, but I also have some mercury pressure pushing down. They have to be equal to each other. If we're no longer moving, those two must be equal. So if I want to find my pressure total, it's the pressure of air inside plus the pressure of the gas inside. All that must equal the pressure outside plus the pressure from the mercury. Well, the atmosphere doesn't really change, so my pressure outside is still 753 millimeters of mercury. And right now, at the end, well, there's 11.3 centimeters difference between those mercury heights. So the extra pressure on the outside from the mercury is 11.3 centimeters or 113 millimeters. So plus 113 millimeters of mercury. Well, I can't add those up. That means our total on the outside is 866 millimeters of mercury. That's got to equal the total inside. So our pressure inside from the original air plus the new gas equals 866 millimeters of mercury. So that answers our first question. What is the total pressure? Well, how do I find the pressure of the new gas? How do I find the second question? Well, I have the total pressure. If I could find the inside air pressure, the white one there, then, well, 866 minus that, the rest must be the new gas, must be in the green X's. How do we go about solving what the remaining inside pressure of air is? Well, we go back to when we pulled the vacuum. For a little while there, we just had less air inside. And so if we think about that arrangement again, it had the container, it had some air, but a vacuum had been pulled. And so we had more liquid up on the inside than the outside. And that difference was 7.8 centimeters. Well, I know the outside pressure at this point. The outside pressure is still 753, pushing down. The inside must be the pressure inside plus that 7.8 centimeters of mercury. So by knowing the height difference when we pulled the vacuum, we can solve how much pressure of air was inside still. The vacuum clearly didn't remove all of it, but it definitely removed some. So the pressure inside plus 78 millimeters of mercury must equal the outside, which was 753 millimeters of mercury. Which means our pressure inside, if I want to rearrange, 753 minus 78, 675 millimeters of mercury, which I can plug in here. 675 millimeters of mercury plus pressure of the new gas must equal the 866 millimeters of mercury we find at the very end. 866 minus 675, our pressure of the new gas is 191 millimeters of mercury. And so we had to kind of look at different parts and different measurements in order to sort out, well, how much of the original air pressure was remaining on the inside. And then as we added the extra gas and pushed the mercury through the manometer, what was the new pressure from the new gas? By comparing those initial states, the first change and the second change, we can solve all the different pressures of those gases.